Point number 5 on the exam. So suppose K is a field and T is a transformation from vector spaces V to V prime and T is linear. Prove that the image of T is a vector subspace of V prime. So definition of the image of T is the image of T is a subset of V prime, right? Consisting of all images under T of vectors in V. So we're also going to be using basic properties of the definition of linearity, these two, and this is a basic property of being linear. Transformation of zero vector is equal to 0. So to prove something, and this is the definition of the set, the image of T. So to prove something is a subspace, you must show these three criterion. 0 is an element of the image of T. X plus y is the element of an image of T whenever X is an element of image of T and Y is an element of image of T. And Cx is an element of image T whenever C is an element of the field and X is an element of image of T. So the first one, we're going to show 0 is an element of image of T. Since T is linear, a basic property of linearity is this property, which is up here I wrote. So transformation of the 0 vector is equal to 0. So since we're transforming, taking the 0 vector in V, and we're applying a transformation of that 0 vector, and it's equal to 0 by this property. Since this is by definition in the set image of T, because if you look at the set, 0, take this X to be 0, apply the transformation to that 0, we get 0. We get T of 0, which is 0. That's inside the set image of T. Okay, so let X plus Y be an element of the image of T. I'm sorry. Let XY be an element. X and Y be an element of the image of T, and C is an element of field. This is a comma. So there exists V and W vectors in V such that you apply the transformation to V, it's going to equal to X. Then you apply the transformation to W, it's going to equal to Y. And these, by definition, are elements of image of T. So we have two vectors V and W, we add them, and apply the transformation. So this is equal to this by linearity, by definition of being linear. And since X is equal to T of V and Y is equal to T of W, get X plus Y is equal to is an element of the image of T since V prime is a subspace. So the last one, since X is an element of the image of T, C is an element of the field, apply the transformation to C times V. Again, this is by definition of being linear. We get is equal to C times X, which is an element of the image of T by definition in the set. And then V prime is, this is true because V prime is closed under scalar multiplication. And by definition, this is inside the set image of T.